Hi, this is George, founder and CEO of Brain of the Store. Today I'm going to give a brief introduction to how our system is put together and how we do machine learning on location data to understand customer and staff movement through retail stores and how we connect that movement to the business results that retailers care about. You're seeing a block diagram of our system here. You can notice location data coming in from the left side into our inbound API. The location data is represented as an XY coordinate with a timestamp, an ID of the person being tracked, a notion of accuracy, is this actually the right person that we're tracking, and a notion of precision, is the XY coordinate that we have there actually the XY location of that person. That all feeds into our behavior engine in the center there, which is really the core of what we do. We implement lots of different use cases in our behavior engine. Today, we're going to talk about just one. And then we have our outbound API that's got a real-time component at the top, which can drive in-store systems like communication devices or tools for a store manager. And then our analytics API at the bottom that provides historical data for doing post hoc analysis, dashboards, and other forms of reporting. Today, we'll look at just components of the system. We'll see the location data feeding in through the inbound API, and then an interaction classifier. We'll do a simplified version of this. It's just meant to show how our machine learning works on these kind of data sets, not to represent a true production class classifier. That'll all come through our outbound API, which will power a representation of a real-time in-store system. We'll have a visualization of what such a system might look like. Here we're looking at synthetic location data that we generated in our own system that runs in the cloud to generate lots and lots of location data for us to train on. That location data here represents a staff member shown in light blue on the left side and a customer shown in darker blue. All the way to the right here, we have some metrics around how our data pipeline is actually operating on that data. At the bottom, we have the number of unique data points per second that are being ingested. Currently, it's pretty low because there are just 2 people in the store. Unique subjects, there are just 2. Up above that, we have some metrics around our inference engine, number of pairs that are evaluated. Currently, that's just 1 pair being evaluated. Positive examples, we haven't found any positive examples using inference yet. And then at the top, we have some metrics on our outbound API, the number of events that it's producing per second, which is currently 0. In the center, we have a plot that displays an example of our interaction inference. We can see that on the x-axis, we have a representation of Euclidean distance. These 2 people are pretty far apart, so they're registering of 0.75 or so in Euclidean distance. And then on the y-axis, a cosine similarity on velocity. This tells us how similarly their trajectories and speeds are as they're moving through the store. Since they're moving towards each other, their velocities are exactly opposite, and you'll notice that they register as 0 on that cosine similarity. The red dot down there at the bottom right shows that the system is not classifying this as an interaction. As they come together and spend a little time together, we notice that their velocities become identical because they're both in the same place, not moving. Their Euclidean distances are much closer together, and the system classifies this as an interaction and understands that they're now interacting. You'll notice an orange circle is drawn around that interaction over there on the left. You'll also notice on the outbound API over there to the right, we've generated 1 event that's being pushed out to our real-time system. As more customers enter the store, store staff moves over to greet them, spends some time interacting, and the system is classifying these interactions in real time. As more and more people enter the space, the system continues operating in real time, again, understanding when these interactions are taking place. These are being fed out through our outbound API. You can see that we're generating more events per second now than we were before. At the inference level, we're evaluating many more pairs per second, finding positive examples, and down at the bottom, we have many more data points per second and about 11 unique subjects currently being tracked at the same time. This is not operating on a heavyweight piece of computing hardware. It's just running on a laptop, and it's still able to operate in real time, generating these interaction events as they unfold. These interaction events would be something that a retailer could potentially capture and use as an analytic later to understand how well staff is interacting in a store, what some of the properties of that interaction are. Did they interact at the right time? How long was it from when a customer came in until they were interacted with, and so on? Or they could happen in real time, driving interactions in store and helping to give tools to the staff so that they can interact more effectively as they're there with customers. You can see that the system is able to follow interactions that take place as they're moving. So a store staff might be shopping together with a customer, showing them different items on the shelf, and the system is able to follow that along. Again, this is just a sample of our interaction meant for demonstration purposes. Our real production classifiers are a bit more sophisticated and produce smoother and more accurate results. So that's how our system is put together. That's the way we use machine learning to operate on these location data sets and how we connect that operation to the business results that retailers care about. Thank you.